Hello students, welcome to our mathematics class. Today we will discuss the last sections of the chapter visualizing solid shapes, and in this chapter we will discuss about polyhedrons and different types of polyhedrons like convex and concave polyhedrons, regular and irregular polyhedrons, and after that we will discuss two broad category of polyhedrons, that is prism and pyramid, and in the last we will discuss one of the most important formula known as Euler formula, which is related to the number of vertices, edges and faces of polyhedrons. So let's start the video. Dear students, on your display now you can see six different solid objects, and out of the six different solid objects, can you identify those solid objects which are only made up of polygons means simple closed figure made up of line segments. For example, triangle, this is also polygon. Quadrilaterals, this is also polygons. In sections of quadrilaterals, there are parallelogram, square, rectangle, rhombus. These all things are quadrilaterals. Then pentagon is also a name of a kind of polygons which is only 5 sides. Hexagon, this is also a kind of polygons, and it has 6 sides. So triangle, quadrilaterals, pentagon, hexagon, heptagon, these all are polygons. So now we will try to find those figures on the faces of these solid objects. On the faces of cuboid has 6 faces, and on the faces of cuboid you can clearly find 6 rectangular faces. So we can say that cuboid is made up of polygonal surface, or a cuboid is made up of polygonal region. Okay, a cuboid is made up of polygonal faces, or cuboid is made up of polygonal regions. Likewise, on the faces of cube you can find square face, or on the faces of cube you can find square. How many square are there? You can see now there are 6 squares. So cube is also a solid objects. And its faces is completely made up of polygon. So cuboid is also made up of polygonal surface, and cube is also made up of polygonal surface. But in case of cylinder, you can see that the top faces, that is circle. So circle does not come under polygon, so it is not made up of polygon. Okay, and sphere, it has only one faces, and that face is not polygon, so we will also exclude sphere. But in case of triangular pyramid, you can find there are different triangle. How many triangles are there in a triangular pyramid? From different faces you can see, and there will be 4 triangular faces. So we can say that in a triangular pyramid we will have 4 triangular faces. So it is also made up of polygonal faces. Or polygonal region. But in case of cone, the base is circle, and the other part is also not polygon, so we will exclude this also. So out of the six solid objects like cuboid, cube, cylinder, sphere, pyramid and cone, only 3 here, cuboid, cube and pyramids, are made up of polygonal surface. So those solid objects which are made up of polygonal faces are known as polyhedrons. Minded students, those solid objects which are made up of polygonal faces are called polyhedrons. That means in this figure now we have six objects like cuboid, cubes, cylinder, sphere, pyramid and cone, and out of the 6, cuboid, cube and pyramid, these are only made up of polygonal faces. So these 3 will come under polyhedrons. Likewise, you can search many more polyhedrons. And what is the criteria? A solid objects will be polyhedrons if its faces are polygons. Okay, if its faces are polygons. All the faces must be polygon. Then we will call this polyhedrons. So why cylinder is not polyhedrons? Because there is circular face which is not polygons. It has one surface, but it is not polygon. That's why it is not polyhedrons. Cone is also not polyhedrons. So let's see other figures so that this concept will be clear. uh, Now you can see that this figure will called polyhedrons. Why this will be polyhedrons? Because it has faces of polygons. What are the different polygons on its faces? The lower one is square, then the sides are side faces are triangle. Likewise, this solid objects will come under polyhedrons because it the sides are, we can say, the surface are polygons. Okay, this it has also surfaces of polygons. So these all figures will come under polyhedrons. And here also we have the four objects. These four objects will come under polyhedrons. But here there are three objects: sphere, cylinder and cone. These will not come under polyhedrons because they have curved surface, and the faces are not polygons. You can clearly see that the faces are circle. Here this base is also circle. So these will not come under polyhedrons. So a solid objects, when we are trying to identify whether that is polyhedrons or not, just we have to see its faces, and when all the faces will be polygonal regions, then we will say that's a polyhedrons. Okay, and on a polyhedrons, the faces made to form line segment. Like here you can see this is one face, this is one face, and when these two faces meet, they form line segment, and this line segment is called its edges. Line segment is called edges, and you can just singular light singular edge. Okay, and when edges meet, and when different edges meet, the vertices is formed. The vertices is formed. So that same thing has been written here. You can note it down. So faces meet and they form edges which are line segment, and edges meet to form vertices which is points. You will always remember that the faces are polygon. Okay, these faces are polygons, and these faces made to form line segment which is your edge, and when edges meet, that form vertices which is point. These all things has been clearly mentioned here. You can make notes, and now you have clear idea about polyhedrons and which are not polyhedrons. Okay, solid objects which are polyhedrons, that means that faces are completely polygonal, regions are polygons. But solid objects which faces are not made up of polygons, that's are not come under polyhedron. Okay, these are not polyhedrons, these are polyhedrons. Now let's see what are convex polyhedrons and concave polyhedrons. Now we will discuss about convex polyhedrons and concave polyhedrons. In our books, only one word has been used, convex polyhedrons, and the other category has only been mentioned like not convex, which we will call as concave. Okay, so first remember what is convex and what is concave in case of polygons. Then we will apply that in case of polyhedrons. In case of polygons, how the polygons were being tested, whether they were convex or not. To test whether a figure is convex or not, just you have to take any 2 points inside the figures and you have to join. And if the line joining any 2 points will completely lie inside the figure, then that will called convex. That will be called as convex. Okay, but when the line joining the different points in the inside the figure will lie outside, then it will called as concave. It is called as concave. So this figure is concave figure, but the first figure is convex. Likewise, let's take another thing. Suppose we have circle, and we have a shape like this. And surely these are not polygons, just they are pictures. Let's try to identify which of the following figure is convex. To test convex, just take 2 points and try to join them, and the line joining the two points will completely lie inside the figure, then that will be convex. So first figure is convex, but in case of second figure it is concave. Okay, so applying this strategy we can also identify which polyhedrons are convex and which are not convex. In case of cube, you can take any 2 points inside the cube and you will join. Surely the line segments will lie inside the cube. That's why this kind of figures, this kind of solid objects are convex polyhedrons, or the kind of polyhedrons will be called as convex polyhedrons. As wherever we will take 2 points and we will join, the 2 points will be inside the polyhedron. The line segment will be inside the polyhedrons. Whenever you will take arbitrarily, you can take 2 points and you will join the line segment that is joining the 2 points will completely inside the polyhedrons. So this kind of polyhedrons are known as convex polyhedrons. But in this polyhedrons, you can see, suppose I take a points on this top and another points on this top, and suppose I'd like to join, then you can see that these parts will be outside the polyhedrons. That's why this is not convex. This is not convex. On this also, suppose I have a points on this top and another on this base, and suppose I join, then this line segment will be completely this part of the line segment will completely outside the polyhedrons. So these all figures may be polyhedrons, but which of these are convex polyhedrons? These two are convex polyhedrons. Okay, and these two are not convex, which we may name as concave polyhedrons. Let me show you other kind of definitions. And the convex polyhedron, a convex polyhedron is just like a convex polygon if a line segment joining any 2 points on the surface of polyhedrons entirely lies inside the polyhedrons. It is called as convex polyhedrons. Okay, wherever you can choose any 2 points, suppose on this face and on this face, and you will try to join, then this line segment will completely lie inside the polyhedrons. That's why it has been named as convex. But in this case, suppose you are trying to join this 2 point, then you can see that this line segment is just outside the polyhedrons. That's why it is concave. Okay, in case of concave, that will lie outside, and in case of convex, every line that you are forming here by 2 points on the surface will lie inside the polyhedron. That's why it has been named as convex. So now you have clear idea about convex and concave polyhedrons. Let's discuss about regular polyhedron. Okay, regular polyhedrons. Let's first see the definition that is given on our books. After that, we will see that definitions. Definition of regular polyhedrons. Okay, regular polyhedrons. A polyhedron is said to be regular if its faces are made up of regular polygons. Regular polygons means polygons having sides of equal length and angles of equal measurement, like equilateral triangles, square, then pentagons with same side and same measure of same angles. So this kind of faces you will find on the surface of polyhedrons. So regular polyhedrons, a polyhedron is said to be regular if its faces are made up of regular polygon and the same number of faces meet to edge vertex. On edge vertex, the same number of faces should be there. Suppose on this vertex, you can find 1, 2 and 3 faces. Okay, and you can see this faces as regular polygon. These faces are regular polygon. Let's see the same thing. Now we have seen our definitions from book of regular polyhedron, that its faces must be regular polygon. Faces must be regular polygon, and on a vertex, on as and every vertex, same number of faces should be present. Okay. So using that thing, we will have only five regular polyhedron. The first one is tetrahedron, and which one is tetrahedron? Tetrahedron is that you have seen. Let me show you again the tetrahedron. Actually, you are acquainted with the name of triangular pyramid. This is known as tetrahedrons. Okay, its base is triangle and equilateral triangle, and from this the upper faces are made, and you can see that this one is its base and it is equilateral triangle, and first side triangle is this side, then another will be on this side, and next will be this side. So total four faces are there, and all the faces are made up of equilateral triangles. So this is tetrahedron. Okay, or we can say it is triangular pyramid. The tetrahedron has four faces, six edges, and four vertices, and the shape of each face is equilateral triangle. So this is one of the example of regular polyhedrons. Okay, and mind it, there are five regular polyhedrons. Now, cube. A cube is also a regular polyhedrons. You are well acquainted with the shape of cube. Let me show you it again. This is cube, and all the faces are square, and you know that square are regular polygons, and on edge vertex 1 2 3 numbers of squares will meet. So cube. A cube has 6 faces, 12 edges, and 8 vertices, and the shape of each face is square. So second type of regular polyhedron is cube. We have already covered two regular polyhedrons. Next, regular octahedron. A regular octahedron at 8 faces, 12 edges, and 6 vertices, and the shape of each face is equilateral triangles. Okay, let me show you regular octahedron. We have regular octahedron. Here we have regular octahedron, and next regular dodecahedron, and it has 12 faces, 30 edges, and 20 vertices, and edge face is regular pentagon. Let me show you regular dodecahedron. Here is the regular dodecahedron, and its face is regular pentagon. Okay, and last one, regular icosahedron, and it has 12 faces, 30 edges, 12 vertices, and each face is an equilateral triangle. Okay, it has 20 faces. Mind it has 20 faces. Let's see it. Here is the regular icosahedron, and these all figures, these are the examples of regular polyhedrons. Okay, these are the examples of regular polyhedrons. So whenever you will be asked to cite examples of regular polyhedrons, you have to cite examples of these solid shapes. And here is two figures where we can distinguish whether why this is regular polyhedron and other is not. Why cube is regular polyhedrons? From definitions of the regular polyhedron, we are acquainted. We have been asked that a polyhedron should be regular when all the faces will be of regular polygons, and on each vertex we should have same number of faces. So in case of cube, all the faces are square, which are regular polygon, and on each vertex we can find 3 faces. So this will be examples of regular polyhedron. But why this polyhedron will not be regular? Let's just see on the top point A, you will find 3 faces. 3 faces are connected but on the point B, 1, 2, 3, 4, four faces are connected. So on edge vertices there should be some numbers of faces, but in case of A and B there are different number of faces. So for this point this has been cancelled out. This is not regular polyhedrons. So to know to verify whether a given polyhedron is regular or not, we have to just see all the faces, whether all the faces are regular polygons or not. Then we have to check on edge vertices there should be same number of faces, and if there will be not same number of faces, then that will not come under regular polyhedrons. Okay, so till now we have discussed about, let's go to the starting. First we discuss about polyhedrons and which are not polyhedrons, solid objects which were polyhedrons, and objects which were not polyhedrons. And what are the criteria to be polyhedrons? The solid objects must be made up of polygonal regions, and if a solid object is made up of only polygonal region, then that is called polyhedrons, and which is not made up of polygonal region, that is not called polyhedrons. So these all are polyhedrons because its faces are made up of triangle, square, rectangle, and pentagon. This kind of figures we are getting. So we can say this kind of solid objects will be polyhedrons, but in this case these are not polyhedrons. Next we discuss about convex and concave polyhedrons. In case of convex polyhedrons, we will join 2 points on its surface, and all the points on the line segments will lie inside. That's why it is convex. But when we will join these 2 points, the line segment will lie outside the object, so it is not convex, so it is called as concave. Okay, and then we discuss about regular polyhedron. In case of regular polyhedrons, the faces must be made up of regular polygons, and on edge vertices there should be equal number of faces. And we know that there are 5 regular polyhedrons, and the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. These are the examples of regular polyhedrons. Now we will see 2 broad category of polyhedrons. One is prism, another is pyramid. Okay, when we will classify polyhedrons, then we can broadly classify them into 2 categories. One is prism and another is pyramid. In this way we can classify. And how to identify prism? It has special property like the base and the top. The base and the top, they are the congruent polygons. Like you can see that on the base, suppose we have a rectangle, then on the top also we will have the same size rectangles, which we are calling congruent polygons. Okay, and in this case also, when the base is triangle, the same kind of triangle and same size triangle is on the top also. So when we will have this kind of solid objects or this kind of polyhedrons, then we will call them as prism. But in case of pyramids, the base may be triangle, the base may be square, the base may be pentagon, and from that all sides will be triangle, and they will be connected to a single vertex. Okay, the base may be triangle, the base may be square, may be pentagon, and from this base all the edges will come and they will meet on a single vertices, so that the side faces will be triangle. Okay, side faces will be triangle. So when we will get this kind of solid objects, we will call as that is pyramid. Okay, so these are the 2 broad category. One is prism, another is pyramid. So what is the basic difference? In case of prism, we will get 2 congruent figure at the top and the bottom, but in case of pyramid we will get a polygon on the base, but on the top we will get a single vertex, and on the top all these triangles will be connected. All the triangles will be connected on the top. So this was 2 broad category of polyhedrons, and in the last sections we will discuss the most important useful formula, that is Euler's formula. To understand what is Euler formula, let's Euler formula is just a relations and that describes between the relations of faces, vertices, and edges of our polyhedrons. Okay, in case of triangular prism, what is the number of faces? You can clearly see that there are 5 faces, 3 are rectangular and 2 triangular. Okay, and what will be the number of vertices? Number of vertices 1, 2, 3, and 4, 5. There another will be just behind that, and there are 6 vertices. And number of edges, you can clearly count 1, 2, 3, 4, 5, and 1 is on that side 6, and on this side 3. So total 9. So these all things you know how to count the number of vertices, number of faces, and number of edges. You can count that. You have also submitted our models, and from models also you can count all this. So let's see what is the relations. Okay, for faces, let's denote it as single letter F. For vertices, let be V, and for edge it is E. Let's try to add F and V. Okay, we will have F plus V. See, F plus V, 5 plus 6, that is 11. And here we have 9. And how to get 11? Suppose 9 plus 2. Or we can say F plus V is 2 more than E. Or when we add 2 with E, it is same. That means F plus V is here in this case E plus 2. Okay, 5 plus 6, that is 11, and 9 plus 2, that will be 11. That means when we add F plus V, that will be same as here E plus 2. Whether it is true or false for other, let's check. In this case 6 plus 8, that is 14, and here 12 plus 2, that is also 14. That means in this case also F plus V is same as E plus 2. Let's check it for other also. Here 6 plus 8, it is also 14, and 12 plus 2, it is also 14. So F plus V, that is same as here E plus 2. We are adding 2 in edges. Then pentagonal prism, let's add this. 7 plus 10, that is 17. That means here F plus V value is 17, and here E value is 15. So E plus 2, that is 15 plus 2 is also 17. So from these figures, from these solid objects, we can say that whenever we will have the value of F, V, and E, the relation that is F plus V is same as E plus 2. This is true for all these. And this relation is known as, or this formula is known as Euler's formula. Now let me write it again here. When we will have polyhedrons, F denotes for faces, V denotes for vertices, and sum of number of faces and number of vertices of a polyhedrons is same as number of edges plus 2 or E plus 2. This formula is known as Euler's formula. You may write this as F plus V minus E equal to 2. Okay, this way also you can write that. And also you can write that this is same thing, F plus V is equal to E plus 2, and this formula is known as Euler's formula. This is one of the famous formula that is being used to verify whether there is a polyhedron or not by counting the number of faces, number of vertices, and number of edges. You will find these relations in all cases. And also when there will be number of faces and number of vertices, you can easily calculate number of edges, and when there will be number of vertices and number of edges, you will be able to calculate number of faces. So out of the three variables, that is F, V, and E, when 2 will be given, the third one can be determined by this relation. Okay, so note it down as the Euler's formula, F plus V. Let write it again. F plus V is equal to E plus 2. It is Euler formula. As Euler's formula, note it down, and after watching this video, try to do the exercise sections. First revise it, first try to understand the result, then you have to do the exercise. And you have to remember the Euler formula that is being asked in different entrance examinations. In near NMS exam, the questions may be asked related to that.